Have you ever looked at a bird's wing, a honeycomb, or a simple leaf and marveled at its perfection? For 3.8 billion years, nature has been refining its designs, creating masterpieces of efficiency, resilience, and beauty. Yet, when we look at our own creations, our cities, our products, our systems, we often see waste, pollution, and inefficiency. We're on an unsustainable path, one that's leading to resource depletion and a changing climate. But what if the answers to our biggest problems have been right in front of us all along? What if we could learn from nature's genius to build a better world? This is the core idea behind biomimicry, the practice of looking to nature for inspiration to solve human challenges sustainably. It's not just about copying what we see. It's about understanding the deep principles that make natural systems work so well. Today, we're diving into the incredible world of biomimicry, where nature's blueprints are sparking a design revolution. Let's start with a classic example that perfectly illustrates this concept: the Japanese Shinkansen, or bullet train. The original models were incredibly fast, but they had a big problem. When they exited a tunnel, the compressed air would create a loud sonic boom, disturbing residents for miles around. The engineers were stumped. So, they looked to nature. One of the lead engineers was an avid birdwatcher, and he noticed how the kingfisher can dive into water at high speed with barely a splash. He realized the secret was the bird's long, streamlined beak. The team redesigned the front of the train to mimic the kingfisher's beak. The result? The new train was not only 10% faster and used 15% less electricity, but it was also quiet enough to meet the strict noise standards. By emulating a bird, they solved a complex engineering problem. This principle of learning from nature extends far beyond trains. Have you ever wondered how a gecko can scurry up a wall and hang from the ceiling by one toe? It's not suction or glue. Their feet are covered in millions of tiny, hair-like structures that create a powerful adhesive force at the molecular level. Scientists have mimicked this to create gecko tape, a super strong, reusable adhesive that can hold immense weight and leaves no residue. Similarly, think of a lotus leaf. Water droplets roll right off, taking dirt with them. This self-cleaning property, known as the lotus effect, is due to a microscopic waxy texture on the leaf's surface. This has inspired everything from self-cleaning paints and windows to stain-resistant fabrics, reducing the need for harsh cleaning chemicals and water. And it doesn't stop there. By studying the bumps on the leading edge of a humpback whale's fins, researchers discovered they dramatically improve aerodynamics. This design is now being applied to wind turbine blades, allowing them to capture more energy from the wind, even at lower speeds, all while operating more quietly. From a bird's beak to a gecko's foot to a whale's fin, nature provides an endless library of proven solutions. The application of biomimicry is now scaling up, transforming entire industries. Take architecture, for example. For centuries, our buildings have been sealed boxes, completely reliant on energy-intensive heating and cooling systems. But now, architects are designing buildings that breathe. The Eastgate Center in Harare, Zimbabwe, is a landmark example. Its ventilation system was modeled after the self-cooling mounds built by African termites. These insects maintain a constant temperature inside their mounds, despite huge daily temperature swings outside. The Eastgate Center uses a similar system of natural convection, consuming less than 10% of the energy of a conventional building its size. Imagine entire cities with buildings that regulate their own temperature, just like living organisms. Biomimicry is also tackling one of our most pressing environmental issues: plastic waste. We produce millions of tons of plastic that take centuries to decompose. But nature has a solution for everything. Scientists have discovered enzymes, like those found in the saliva of waxworms or certain bacteria, that can actually break down plastics. Startups are now developing industrial processes that use these enzymes to digest plastic waste, turning it back into its basic chemical components to be reused. This creates a truly circular economy for plastics, inspired by nature's own cycles of decay and renewal. And what about the carbon in our atmosphere? We see it as a pollutant, but plants see it as food. Photosynthesis, the process plants use to turn sunlight, water, and CO2 into energy, is the most successful carbon capture technology on the planet. Researchers are now developing artificial photosynthesis systems that mimic this process to capture atmospheric CO2 and convert it into clean fuels or valuable materials, turning a problem into a resource. Looking ahead, the potential of biomimicry is truly mind-boggling. We're on the cusp of creating living materials, concrete that can heal its own cracks, inspired by the way bones mend themselves, or bricks grown from bacteria that absorb CO2 as they form. This could revolutionize construction, creating infrastructure that is not only more durable but also regenerative. Our entire approach to agriculture could be transformed. Instead of vast, vulnerable monocultures, we can design farming systems that mimic the diversity and resilience of a natural forest ecosystem. This approach, known as agroforestry or permaculture, produces food while also restoring soil health, conserving water, and creating habitats for wildlife. On a global scale, these biomimetic strategies offer real, tangible pathways to address climate change and resource scarcity. By aligning our technologies and systems with the principles that have sustained life on Earth for billions of years, we can move from a model of extraction and consumption to one of integration and regeneration. The future is not just sustainable, it's biomimetic. So, how can you start to see the world through the lens of biomimicry? It's simpler than you think. The next time you go for a walk, pay attention. Look at the branching pattern of a tree and see how it maximizes sun exposure. Notice the spiral shape of a seashell and think about how it allows for strong, efficient growth. Ask yourself, what problem is this organism solving, and how is it doing it? The solutions to our greatest challenges are all around us, hidden in plain sight, in the elegant designs of the natural world. Nature has already solved the problems of energy, food production, climate control, and waste management. It's time for us to stop trying to reinvent the wheel and instead start learning from the master inventor. The blueprint for a sustainable, thriving future has already been written. It's written in the language of life itself. Thank you so much for joining me on this journey into the world of biomimicry. I hope it's inspired you to look at nature not just as something to be preserved, but as a mentor to be learned from. If you enjoyed this video and want to explore more ideas that are shaping our future, please hit that like button and subscribe to the channel. We'd love to hear your thoughts in the comments below. What's your favorite example of biomimicry? Until next time, stay curious.